changes in standards. They plan and execute to be ready for when changes occur. In 1994, IBM's mainframe industry was rapidly crumbling. Then CEO Leo Gerstner listened to his customers and heard their need for integrated solutions addressing the new industry paradigm. What an intro that was. So similarly, the broadcast industry will increasingly need integrated solutions, exactly like the way Leo Gerstner saw it for IBM back in 1994, that will provide interconnectivity and interoperability between different vendors' products. Now, Belden's merger of Miranda and Grass Valley created the broadest product portfolio in the industry, and the merger has put in motion efficiencies for both manufacturing and other business processes. Now, the merger was essential in bringing together research, development, and engineering expertise to truly innovate and adapt to disruptive technologies to best serve our customers. Belden's commitment to the broadcast industry is steadfast. In fact, Belden's broadcast business is now 40% of the total company's top-line revenue. It is a diversified company, both in terms of industries and geography, which creates very sound financials that are imperative to weathering the perfect storm, as I mentioned earlier. Belden's business system makes Grass Valley a company that is proactively addressing the industry headwinds in its own business by reallocating resources to ensure our viability, flexibility, and agility to be the best partner for our customers, while at the same time we are maintaining fully our strategic investments in innovation that will keep our customers future ready in all the applications that they serve, by enabling them to tell better stories efficiently and profitably with innovations in IP, 4K, and digital media. And now, to tell you about some of these great and exciting launches that we're introducing here at IBC, I'd like to invite Mark Hilton, one of our vice presidents within the strategic marketing team, that will speak about Grass Valley's IP, 4K, and digital media launches of the future. Thank you, Mark. It's all yours.
Great. Thank you, Marco. Great to be here. Appreciate your time. So I'm excited to tell you about some of the advances we're making, bringing to the market to enable telling better stories more efficiently. If we think about the market that we're in, I'm confident that we're all sort of feeling this acceleration. If we look at a couple of numbers to try to get our hands around what this means. 1934, that was really the year that broadcast began with black and white television. Probably not a lot of us remember that date, but that's about the time it started. 1972 is when color television really became to the fore. 2002 is when we saw moving to high definition really take off and penetrate the market. We expect next year, 2016, to be the year of 4K. And we also have customers now telling us, plan for 2020, 8K. So as you kind of look at these numbers a little bit differently, instead of just the raw numbers, the difference between those took us 38 years to go from black and white to color. It was only 30 years to go from color to high definition. 14 years now, we expect the 4K, and maybe as little as 4 as we move to 8K. So there's this acceleration. We're definitely feeling it in the market. The technology also is accelerating. So these are kind of the forces that we're dealing with in the market. Now, we talked a lot about IP over the last several trade shows. We introduced products at NAB around our glass-to-glass solution. IP is a critical element. It has lots of benefits in terms of being agnostic to all these formats that we just talked about, to be reduction of cabling, to provide flexibility. But in the end, IP is all really just the first critical step to really where we want to get to, which is more of a flexible, agile, data center-like environment that we see many other vendors taking advantage of in other industries. Companies such as Google, Hulu, Netflix, Amazon, they are already taking advantage of these data center distributed architectures and their over-the-top services, and they're able to bring these to market very quickly. How are they doing that? They're doing it with a distributed data center architecture. The basic structure is quite different than what we've used in broadcast for years, and we're seeing a real advantage in terms of agility and the ability to respond quickly to market dynamics. So why is a data center so interesting? What are some of the key elements? Well, we see a number of them here. Certainly the agility of service deployment. This is the ability to stand up an application and spin up some new channel or some other capability that the market is requiring. In today's architecture, that can take months, if not years sometimes, in terms of adopting 4K. You need an entirely new infrastructure. Whereas with a data center, bandwidth-driven kind of architecture, these things can be adopted much more quickly. Scalability as well. How do you scale incrementally without having to rip and replace entire infrastructures? Is something that a distributed architecture gives you. You can add new components and elements as you grow out your data center or your network that supports that. The efficient use of compute resources. Historically, we always had one box that did one thing. And now as we move into the virtualized world that we see in hosted cloud environments, the utilization has gone from sometimes 5% up to 75–80% on those compute assets, those resources that are so important. And so we see data centers taking advantage of that. Things that are more technical for the broadcaster is the idea of non-blocking. Being able to move data from any point to any other point without blocking, without having collisions. And this is certainly something that data center networks can provide as that bandwidth is available. Graceful fault tolerance as well, because of the distributed function. You have multi-paths through that network, and if you have one of the nodes or one of the components fail, you can heal that much more quickly. And of course, the ease of upgrade, the actual devices themselves, is very important in terms of maintenance. So lots of good things here that come from a data center. So if it's so great, how come broadcasters haven't adopted this sooner? There are a few things that have impeded the progress of this type of architecture, which we at Grass Valley are attacking directly. One is this high persistent bandwidth. So in a typical data center, you have very statistical, spiky sort of demands, whereas in a broadcast data center, you would need to have high throughput at a continuous rate because of the real-time nature of our streaming. Lower latency. Obviously, our applications are very latency sensitive, especially in a live environment. If you look at some of the computation that we need to do with video, it is very sensitive to the type of compute infrastructure that you have. x86 is the typical server architecture used in a data center. And it turns out that with some of the FPGA and other sorts of DSP devices, that you can actually have a lower power, lower consumption required compared to x86. And one that we think is really critical is this concept of vertically actively switching a signal. A data center is not able to do that with the common off-the-shelf hardware that we have today. Another way to look at this is to look at how have IP infrastructures been deployed to date in our market. Certainly we've made a lot of progress around IP. There are some solutions out there today that are using IP. What we find, however, is normally they start with a large monolithic core box that is IP, but around that is wrapped a layer of conversion. These are gateways, if you will. and then you plug SDI products into it. So it's not really that efficient. It's not providing a lot of the advantages that we want to see in a data center in terms of being scalable and manageable. So what if we could take a lot of the benefits that you get from a data center, which we've already listed, a traditional data center, but with the performance needed in broadcast. And this is what we are calling the Grass Valley Broadcast Data Center. It takes all the goodness that we have there, adds low latency, programmable FPGA blades, and vertically accurate switching. This is a concept that we have and that we are developing and innovating in this area to bring this to the market, to really step into where IP needs to take us in the years to come. So we're going to be delivering this agile IP-based infrastructure which will be capable of meeting these needs. To do this, we really need a breakthrough product, a new category. We have to think differently than what we've historically done. If you look again at this network, this distributed network that has multi-tiers, and we stood back and said, where can we innovate as Grass Valley? Should we start in the core or the aggregation or the edge? What are some things that we can do? We realize we still need traditional broadcast I/O interconnects. We have to have products connected into this data center somehow. It's not just a bunch of x86 servers. And we need this flexible processing that's optimized for video. So this is where we have focused our innovation, in the edge and the processing and the connectivity. So we're proud to introduce what we're calling GB Node as one of our first products to this market that will focus at that edge and provide the kind of capability that we believe is necessary to enable this vision of a broadcast data center. It's a combination of many traditional products fit into a single small platform. We call it a node because it's a component of a larger distributed fabric. It can stand alone and work on its own, but it also can collaborate with other like products. Specifically, it is an audio-video processing NIP. We can handle the audio and the video independently. It's a distributed routing component, as we stated, and it switches vertically accurately. So addressing some of the key elements that are missing in the traditional data center today. In addition, we are aggregating all of the bandwidth in that box and providing an aggregated connection through high-speed 40 gigabit connections out to the larger fabric. So a little more detail on this. It's a modular product, essentially, that has an here's an example. There's 16 slots. You could use some of those slots for devices that are IP, over 2022-6 as the format. SDI has embedded multi-viewers, the Kaleido quality multi-viewers, as well as some general purpose processing. All of that is aggregated over an internal switching fabric which provides a whole single terabit per second of bandwidth available. Another way to look at this is each of those little boxes represent a GB node. You could connect them together by just plugging them into one another into a small little fabric, if you will, with IP, SDI, processing, multi-viewing, etc. in that. If you want to scale beyond that, we would then connect into a generic COTS environment, such as a Cisco, HP, Arista, some product like that would provide that second layer of aggregation and the high speed necessary, such as in a data center. And we can do this in a graceful fashion, scaling at wire speed, non-blocking. We can scale this really up to very, very large sizes, 6,000 by 6,000, with just a single hop, and even larger with multi-hops. So we've announced, we're talking about this broadcast data center. It's an additional concept that fits nicely into our glass-to-glass story that we've been telling and the solutions that we're bringing to market. Glass-to-glass meaning from the camera all the way to the monitor. This data center is really focusing on a way to to bring that together from an infrastructure perspective and allow the various components to plug into it. So we're focusing on this to give business flexibility and agility. Now, IP has brought us into a lot of different areas, a lot of standards. We're working with SMPTE on a number of these things. You'll see here on the show floor, we're participating in the VRT live IP, which is it's a demonstration here at IBC, and then it's an interoperability testing that's been going on. So we have 3, I think, of our products participating in that solution. We are heavily involved in the VSF activities, and we've announced our participation in the TICO Alliance, which is using the TICO technology for 4K over 1 wire. 4K is we believe is a critical direction that we need to go. We are supporting this across our products. You can see from our cameras, through our routers, our production switcher, replay, and monitoring, we have complete 4K capability that we've announced. As part of that, we announced at NAB the LDX Universe, which is a licensable product that will support 6X, HD, or 4K, so very economical. As a companion to that, we have the Dino Universe that also will support 6X and 4K using solid-state memory. So these were announcements at 5 months ago. But if we think about UHD, it's not just about 4K. 4K is resolution. It's interesting, but as you really look at trying to enhance the experience, the immersive experience in television and make it more lifelike, think about a flower. Outside today, if you looked at a flower, that would measure about 15,000 nits of brightness from the lowest to the highest. Just as an example. Television display can do 300 to 400. So we're compressing that natural experience into a very small area. UHD has the promise of providing a broader range, a higher dynamic range. So with that, we're happy to announce our extended dynamic range product capability with our LDX solution, part of our LDX 86 series that will provide up to 15 f-stops. This is 50% more than that we're aware of other solutions that might be available in the market to give the kind of dynamic range that will give us that lifelike experience and really take us to where UHD is promising. And with that, I'd like to pass it off to my colleague as he talks. I've been focusing on production, telling better stories efficiently. Ian Fletcher, our CTO, will talk about how do we deliver that out, through a playout. And so, thank you very much.
Thank you, Mark. Afternoon. At the risk of making you all feel old, it's actually 10 years ago that we first showed ITX, launched ITX at NAB. Looking around, quite a few faces were there. So I'm afraid, yes, it is 10 years. I was rather hoping at that point the marketing team would take that as a hint to bring a big cake on for us all, but it seems that they didn't take that hint. But it's 10 years old, and I can tell you one thing, I had a lot more hair then than I do now. But it's been a very successful product for us. We've got many thousands of channels on air around the world now, and these are very high value channels. These are high-end networks doing real primetime television. And over those years, we've learned many things. We've made some mistakes. We've learned from those mistakes, and we've been adding more and more features into the product as the customers have kind of demanded that they want to try and consolidate more of their broadcast chain. But the trick with technology is you can't stay in any one platform too long. You have to continue to innovate, continue to sort of jump technology platforms. And one of the great things about being part of the Belden organization, as Marco was saying, is we've spent a lot of money on R&D. And so we've had the luxury of, whilst continuing to develop ITX and continuing to sell ITX to our customers, we've had a completely separate team that's been working on a completely brand new engine that sort of forms the core of ITX. And we've been battle hardening this in the field, and in fact all ITXs we've been shipping really this year all have this new engine inside them. And this has been a seamless transition for customers. This is the internal technology that fits inside the ITX engine. And really what we've been focusing on is trying to get more and more of the transmission chain, focusing on higher quality, setting ourselves up really for the challenge that Marco sort of talked about in terms of broadcasters needing to do more and more, often with less resources. And targeting increasingly now not just baseband, but also obviously IP, virtualization, and also VOD and file-based content, which I'll come on to shortly. And this engine's also 4K capable. We've already shown it running 4K. So it's resolution independent, it's frame rate independent. And as we start to get into things like HDR, the engine's flexible enough that we'll be able to do that as well. So this is one engine that basically we can use anywhere within our product range. We don't want to have 5 different ways of decoding video. So basically this same engine is used across a range of our products and more to come in the future. So it gives broadcasters more inputs, more outputs, flexibility of whether those inputs are baseband or IP, or whether the output is baseband over IP, ability to get more density if you're using it in a virtualized environment, and a lot more work on audio with support for obviously all the kinds of Dolbys and the continuing enhancements in that area, and also taking advantage of our in-house audio loudness algorithms and building all of those into the engine. So there's some of the, there's hundreds of other changes as well, but they're kind of some of the high-level things that people are benefiting from. And the other big thing, really, and this is something that we've really benefited from with our acquisition of Softel, is around the whole closed caption space. I mean, this is one of those parts of the broadcast industry that's a real black art still, you know, especially when you get into multi-language subtitling and DVB subtitling. It's not the sort of thing you want to sort of learn how to do the hard way. So having that technology in-house has enabled us to wrap that within to ITX now. So we've got very, very sophisticated support for all of the closed captioning directly in the playout chain, but also at the desktop as well. So if operators are just previewing a piece of content, they see all of the same experience. They see all the closed captioning being burnt into the screen, so they can do a full QC of that video asset, which is very important. And they know that if they can play it on their preview screen, they know it's going to play on air, because it's exactly the same software running exactly the same codecs. And that is a problem, because one of the things we learned as over the last 10 years of doing ITX is the trouble with file-based workflows is that it's a bit of a wild west in terms of wrappers and formats. So even with standards like MXF, if you talk to anybody who actually works at the sharp end, they'll tell you there's no such thing as a standard MXF, because everybody's got their own flavor of MXF. And so companies like ourselves that have to play out all this stuff have had to, over the years, kind of work out how to sort of get compatibility with all of these different flavors that have been created by lots of different video server vendors over the years. So another big area for us that we're really now starting to move into is VOD. And I'm not sure which part of the dragon that is, but it's an interesting graphic. Thanks, marketing, again. So this is something that we see as a real major challenge for broadcasters. As I travel around the world and visit major broadcasters, I see the same problems over and over again. VOD is often something that they've bolted on to their existing workflows. Often, although it's increasingly becoming important to them in terms of revenue, often it isn't generating a huge amount of revenue, and yet it's costing them a lot of money to do. It's not uncommon to see them bringing in content twice, ingesting it twice with completely separate teams, with completely separate tool sets, and then going through completely separate workflows. And that just, you know, simply isn't cost effective. You just can't continue to work like that, especially with the continued explosion of the platforms that they have to deliver that to. And the particular problem is catch-up TV. You know, how long does it take you to get a live show or a section of your playlist on air available. And that's a particular problem in the US where they have what they call the C3 window, where if you play out, if people watch your show or parts of your show within a 3-day window, you get kind of the full credits for that. But the trick is you've got to make that available immediately. And so, again, I see hideously complex workflows. Many broadcasters simply record their own output, take it into a, pop it up, probably put some headers and tails on, transcode it into all the 15 different flavors they need, and then push it out to the various platforms. And that can take hours. I mean, I know broadcasters who take up to 24 hours to get their own output available as a VOD asset. And we think we can do far better than that. Because if you treat it as part of the same process and the same technology as your linear channels, then you can achieve some massive benefits. So we like to talk about mastering. This is an area where we think, as part of the traditional playout workflows and traditional playout chains, we can really deliver the master assets, which may then still go through third-party encoders and transcoders if they need to. But by handling the mastering side, we can take the huge part of the workload away from the broadcasters, because we've got all the assets, we know all the ins and outs, we're playing them out so we know the precise times things start and stop. So it makes much more sense to have your transmission systems make these master assets at the point of playout, or even in advance of playout, because you've got all the assets, you've got the playlist, so therefore why not print, effectively as we would call it, print to file that playlist. And it means you can use the same operators, the same assets, the same playlists, all the same effects that you would normally have, branding, secondary events, logos, all of those things can happen. So we have this ability to run this faster than real time. So if you give us a playlist, in standard BXF format, with all the secondaries, exactly the same pieces that you want, we can print that up to 2 times faster than real time to make a master asset, which can then be fed into your existing VOD workflows. But the real strength comes when you get into the live catch-up TV scenarios. So this is a real example from a big customer that we've been deploying this with actually in Europe. So this is a situation where they have a live sports show. You've got commercials, you've got first halves, then studio links, then you've got the second half, and obviously commercial breaks within that. But what they want available online is just the live event. They don't, in this case, it's not quite like the US. They don't want the same commercials. They want just the live event without commercials, but they do want to add some promos and bits and pieces on the head and the tail. So all of that metadata, that's what they want to happen, is stored in the playlist, and at the point the event starts, frame accurately, when the operator goes take next, we start to create a master. Because we can now record our own output within the same box that's doing the actual linear channel. As they enter the end of the first half, we know frame accurately where that's ended. We're able to then stop the recording or pause the recording. And then the studio links happen, and then it carries on after the commercials. But critically, whilst that's happening at the 50 megabit mezzanine level there, which is what we're recording on what we call the VOD master, our transcoders are playing catch-up, doing the transcoding. So with most systems, you have to wait until the whole program is finished before you can then take that recording and transcode it. We're able to transcode effectively sort of about 1 minute behind ourselves as the live show's going along. And remember, when they go to the commercial break, we don't want those in the VOD master in this case, so we can pause that transcode operation, let the commercials go through, and then pick up afterwards. So the end result is literally within a minute to 2 minutes. In fact, this particular customer, we have an SLA with them of less than 10 minutes, but in reality, it's always much quicker than that. Of any length show, even if it's a 2 or a 3 hour live event completing within less than 10 minutes, that asset transcoded into all the flavors is available for putting on the online platforms. And that's just massively more efficient than other ways of doing it. And they've not needed any additional staff or systems to do that. So by pulling all of these different things together, the media, the metadata, the business rules that are all defined in our workflow systems, we can drastically streamline that operation. And that's just made a huge difference to their bottom line. And it's not just about live play out as well, because you have exactly the same issue in news. And so with our Stratus news product, it's a very similar story, except it's a bit more of a non-linear workflow, because as the stories are produced during the day, the journalists are able to mark any story at any time as being available for the web. So they can choose to publish it to the web before it goes on air as part of the newscast, or they can leave it to record it as part of the newscast. And again, because we're doing the play out, in this case with our Ignite system, we know frame accurately where the stories start and end, we can top and tail them, and then we can push those assets very rapidly out on and put them available online. So it's all about delivering those significant cost savings, driving efficiency in the broadcaster, which of course improves profitability. And remembering, of course, that ultimately this is about the creative side of the business. It's about telling those stories. And we think that by using these technologies, we can do that so much more efficiently. So that's it. So thank you very much. Very, very quick view of what we've been up to there. And I think now we'd be happy to take some questions. And Dave will sort of chair that section. So thank you for your time.